Hey guys, it's Chris at Highline Guitars. You're watching another one of my YouTube guitar building videos. If you're new to my channel, welcome. I hope you'll enjoy this video, and by the end of it, I hope perhaps I'll have earned your subscription. What I'm going to talk about in today's video is I'm going to be covering part 2 of my V guitar build project. And what I want to do is spend a little bit more time talking about the process that I follow for designing a guitar on my computer so that I can make it using my CNC machine. And this is a process that will involve a number of different steps, primarily with software. I tend to look at the process of using CNC technology as having two main overarching processes. The first is the front end and the second is the back end. With the front end, that's where you're doing all the design work on the computer and preparing the files. The back end is where you're sending the resulting G code to the machine to carve out the different parts, the body, the neck, and the fretboard. So I'm going to bring you in a little closer. I'm going to show you some of the different things that I have to do in preparation, as well as kind of walk you through the workflow process that I follow on the front end. And we'll do this hopefully just in this episode, but it may end up extending over into another episode depending on how detailed I get. So let's jump in and get started. In the past, I have always advised that before you start any cutting, carving, and sanding, you want to make sure that you purchase all the parts and the materials that you're going to use so that you can measure the different components and then to make sure that they're going to work well with the design that you've created. However, if you haven't even created the design yet, it may not be possible to purchase all the components because you're not entirely sure what it is you're going to use. Those decisions are often made as you're designing the guitar, but you may have an idea ahead of time as to what type of bridge you want to use, the type of pickups that you want to use, and you can go ahead and get those. But you always want to be aware of the possibility that you're going to have to make some changes along the way if you discover that the design that you've created isn't going to work with the particular parts that you purchased. Or, and this is more likely, you're going to have to modify your design to accommodate the parts that you're going to use. And with this guitar, with this V-shaped guitar, I knew that we were going to use a Floyd Rose tremolo system, and this is the one that I'm going to be using. This is manufactured by Gato in Japan, and it is, in my opinion, one of the best licensed Floyd Rose designs that you can purchase. It's affordably priced and it's extremely well made from very high quality components. So when it comes to designing the guitar, the first thing I have to do is I have to measure the string spread at the bridge. And I'll do this from the center of the string slot in the saddle, from the high E to the low E. And I will carefully measure that out. And in this case, it's 2.138. So what I'll do is I'll round that up to like, 2.14 inches. And I'm going to write that down here. So I will write down the bridge. I'm just going to call it SS for string spread, and that's 2.14 inches. Then I have to do the same thing with the Floyd Rose nut. I want to measure from the center of the high E slot to the center of the low E slot. And sometimes these dimensions are provided by the manufacturer, but I still like to measure it myself because there's always the possibility that the measurements that a manufacturer will supply on, for example, their website or at a retailer may not be correct. So in this case, the nut string spread is 1.3485 inches. And I'm doing these in inches because I'm in the United States. Most of the people watching my videos are in the United States, so I'm going to stick with imperial. I know that irritates a lot of folks, but I'm sorry, you'll just have to make a conversion yourself if that's what you would like to do. The next measurement I have to take is from the center of the high E slot to the outer edge of the nut. And that is 0.15 inches. So we're going to call that overhang. And that is 0.15 inches. And then I'm going to double check from the center of the bass string to the outer edge, and it's the same, which is good. That makes things a lot easier. So then I'm going to measure the overall width of the nut. And when I purchased this nut, I knew ahead of time that I wanted a 41 millimeter nut, and 41 millimeters is roughly 1 5/8 inches, roughly. So to be precise, it's 1.619 inches. Well, I'll round that up, 1.62. So nut width is 1.62 inches. Okay, so I've got these basic dimensions, and this is where I start when it comes to designing a guitar. This is going to allow me to lay out the fretboard and the neck, and then from there I can plan the body. So we're going to jump over onto the computer and continue. What you see on the screen is a website called FretFind 2D, and I'll put a link down in the description below. But this is a website that I use to lay out a fretboard, and in my opinion, the first thing you need to do when it comes to designing a guitar is to lay out the fretboard, because the fretboard is the most important part of the instrument. It's where all the notes are made, and everything centers around the design and the layout of the fretboard. So that's where I start out. And I'm going to use all those measurements that I wrote down earlier. So if you look at the screen here, this web page, don't be put off by all these numbers you see at the bottom of the page. You can completely ignore those. What we're interested in is what's happening over here on the left side. And for the units, I'm doing inches, as I mentioned before. And then for display, I just leave these checked as the default. I don't really mess with those. But the first thing I'm going to do is the scale length. And as you can see here, you can do a single scale length, multiple, or you can do individual string scale lengths. So I'm just going to leave it at single, because this guitar is going to have a 25.5 inch scale length. Then for the string width at the nut, what I had written down when I took the measurements was 1.3485 inches. That's at the nut. Now the string spread at the bridge was slightly different. It is 2.14 inches. And I'm going to leave equal spacing. You can also do proportional. I find that proportional can be a little more precise, but it doesn't really matter all that much. So I'm just going to leave it as equal. Now fretboard overhang, that's the distance between the center of the outer strings, your high E and low E, and the edge of the fretboard. 0.09375 is the default, but when I measured the nut from the center of both the high E and the low E strings and the outer edge of the nut was 0.15 inches. So I'm going to type 0.15 inches. That way the fretboard that's being laid out here in roughly the center of the page, or left center of page, is going to reflect that dimension. And then calculation method, don't worry about that. I just leave it the default. Number of frets. When I'm laying out a fretboard, I know that I'm going to have, 21, 22, 24 frets. In this case, this guitar is going to have 24 frets. But what I like to do is to add an additional fret. That is going to show me the end of the fretboard. So I'll type 25 for the number of frets. And then number of strings is 6, of course. And then I don't mess around with the tuning for the individual strings. I just leave it as is. But then what I can do is I can save out in a number of different formats. So if you're using a true CAD program, you can save it out as a DXF. I don't mess with the multi-page, but what I typically will do is save it out as a single page PDF. You can also do SVG, CSV, HTML, tab, whatever. But I'm going to do a single page PDF. And when I save it, it's going to download to my computer into my downloads folder. And from there, I'm going to move it over into my folder where I'm keeping all the elements that I'm going to be generating for this design. I basically use 5 different software solutions to design a guitar. As I just demonstrated, I use the FretFind 2D to lay out the fretboard. Then I use Adobe Illustrator, I use Rhinoceros 3D, I use Meshcam, and then I use Easel, which is sort of the overarching organizational software. It's where I put all the components together. I do some layout, and then I use Easel to send the project files to the CNC machine as I cut out each part. So what you see on the screen right now is Adobe Illustrator. Now, why do I use Adobe Illustrator? Well, a couple of reasons. First of all, I've been using it for decades, so I'm comfortable with using it. Second of all, I don't really need a true CAD program to lay out the 2D files. I can use Adobe Illustrator and that works fine. Plus, I use the resulting files for other purposes. So I like to start out with Adobe Illustrator. And what I've done here is I've opened up that fretboard that I created in FretFind 2D in Adobe Illustrator. And this is how it comes into Adobe Illustrator. You can see the perimeter shape, you can see each of the individual frets, the strings, and the center line. Now, I need to make some adjustments to this file because it's not quite ready to be used yet. I can bring it into the start of my design, but if you look closely, when I select a fret, it's actually in segments, and I need them to be all one segment. Now I could select them all and join them together, but there's some other things that I need to do first. Because since I'm doing this on a CNC machine, when I cut the fret slots, I can cut the fret slots so that they stop short of the edge of the fretboard, creating what are known as blind fret slots. That way I don't have to bind a fretboard and I don't have to worry about the frets sprouting out from the sides when the humidity levels change. Now, to begin the actual design process, what I'm going to do is create a new document. I'll leave this one open, but I'll create a new document that is going to be 48 inches wide and 36 inches tall. And what that is this shape in here. This is the document. This is going to be for a full-size two-dimensional drawing. And then what I'm going to do is I'm going to copy all of the fretboard elements, and I'm going to bring them into this new document, and I will rotate them, because I like to work on a horizontal view. And this is obviously top-down, two-dimensional. But what I need to do is I need to redraw the fretboard, because like I said before, these are all broken up into individual segments, which I don't want, and I also want to have my blind fret slots. So really, I think the best way to do it is to use guides and lay those guides out and use those as I draw the shape of the fretboard. So I'm just going to draw out guides to each of the frets. Okay, now I am going to place one at the nut position and then one on the what was the 25th fret, which is actually the end of the fretboard. So then what I want to do is bring down another guide, and I'm going to use this to indicate the taper. And I have to unlock my guides to do this. So I will unlock guides. I will select that guide, and then I will place a rotational tool right there at where that guide intersects where the nut is. And then I'm going to rotate that so that it is in the same angle as the side taper. And I will do the same. I'll rotate this one to match, like so. Now, remember how I said I want to do blind fret slots? Well, I have to indicate where the fret slots are going to stop before reaching the edge. So I'll select this guide down here, and then I'm going to bring up my preferences. I'm just using a Command K keyboard command. And I'm going to type 0.07 inches. It's a little bit more than the 1/16 of an inch. But then what will happen is I'll hold down the Option key and hit the arrow key on my keyboard, and that creates a copy of that line 0.07 inches inside of the outer taper. I'll do the same with that top one. So now what I have is the layout of the fretboard, including the frets, including the taper, and including where the slots will stop short of the edge. So what I can do now is I'm going to lock down my guides so that they don't move. And then I'm going to select the existing fretboard, and I'm going to hide it for now. Then what I can do is start to draw in the different elements here. And I can start by drawing the taper. I'm using my pen tool to draw the taper. And that's how that will work. Now what I'm going to do is I'm going to zoom in, and I'm going to start to draw each of the individual frets. And I have my Smart Guides and Snap to Point selected here and here. And what that will do is it allows me to position the pen tool so that it snaps right to the intersection so that I can draw, and that's the fret. And then I get an extra bit of line since I'm drawing, so I just click it and then delete. And then I will continue to draw the frets, just like that. Now once I finish drawing in the frets, I can hide those guides. I'm not going to get rid of them, I'm just going to hide them. And that's what the fretboard is going to look like. So you can see the fret slots, they stop short of the edge. You see the perimeter shape. And now what I'm going to do is I'm going to bring back the initial fretboard shape that I had created in FretFind 2D and then hid while I was drawing these out. And I'm going to group everything so that it's easy to select. But now I can see where the nut is going to begin and then where my scale length is going to end. This is going to be where the bridge will be placed. So I can start to plan out the layout of the body with the bridge, and I can start to plan out the layout of the headstock design, and I can also start to think about where I'm going to position my pickups. So it's a pretty simple approach, and as I said, I like to make sure to do this fretboard first. Now, as you can see here, the design has been completed. And I don't really want to get into a detailed tutorial on how to use Adobe Illustrator because there's plenty of other tutorials out there on how to use it. And you may not even use Adobe Illustrator. You may decide to use a traditional CAD program to create your design. So I'm not going to waste everybody's time by explaining how I draw the different shapes. I'm really more interested in explaining the concepts behind the process that I'm using and some of the things that I do so that you can be aware of that as you're doing the work yourself. And once I have the fretboard drawn in with the frets and the perimeter shape, one thing that I had to change was this area at the front of the fretboard. This is where the Floyd Rose nut is going to sit. It has to sit on a shelf at the front of that fretboard, so I had to extend out the lines to accommodate that shelf. And then once I had that, I was able to start laying out the basic design for the guitar. So I was able to lay out my headstock and then the shapes of the body, the pickup pockets, and then the all-important recessed Floyd Rose design. Now, when I'm doing this sort of work, I'm trying to think about how I'm going to use these elements when I start to create my 3D models that I'm going to use in the CAM process. So I have to think about, for example, what is going to be the top, which parts are going to be the bevels, and I want to make sure that once I bring those elements into my 3D CAD program, I'm going to be able to utilize those elements to quickly generate my 3D model. So you have to think that stuff through, and it takes experience of going back and forth. You start to figure out different ways to lay out your drawing and to connect all the elements together so that you can quickly create the design in 3D. And a good example of that process is this recessed bridge. And what I did was I went to, I think it was the Schaller website, and I downloaded the 3D, well, I think it's a PDF file that shows how to lay out the cavities for the recess for a Floyd Rose. And I knew from experience and past guitar builds that I've done that the Schaller plan works well with the Gato bridge that I'm actually going to be using. But when I laid it out here on my 2D Illustrator drawing, I created the shapes based on knowing how I'm going to carve this in 3D and how I'm going to set up the 3D model. I want to make shapes that are easy to extrude when I'm developing that. Same thing with the spring cavity, all those different elements. So you can see how I sort of did that here. So you have to think about how you're going to build your 3D model and the best and most efficient way to create those shapes to make that process as easy as possible. Another thing that I did was I created my inlay design. And for this particular project, it was fairly easy in that I found a good resource for a rose, which I imported, and then I modified it to my tastes, and then created just a simple black and white design here. It's just a simple vector. And that's going to be useful later on when I create the G-code files for carving the inlay on the fretboard. And so it was pretty easy to create that design. For the headstock, the design was dictated by the customer. So I knew kind of what we were going to do as far as the shape is concerned. And it's, as you can see, it is going to be a reverse headstock. And one of the things that I like to do when I'm laying out these designs is I like to try and figure out how the strings are going to extend off of the nut and to each tuner. And as you know, a lot of folks like to go for a straight string pull. But one thing I'll say about designing headstocks is when you start to constrain yourself with, for example, inline tuners or 3 on each side, or straight pull, string from the nut to each tuner, you begin to constrain what you're going to be capable of designing as a headstock shape. And one thing I've told people in the past is, don't get hung up on your headstock shape. The problem is there are a limited number of headstock shapes that you can come up with, and I can promise you that every headstock shape imaginable has been designed by somebody at some point in time. So if you are going to struggle with trying to come up with what you think is the beautiful, creative, original design that nobody else has done before, I promise you somebody has, or something very similar. So don't get too hung up in that. Really all you want to try to do is to create a design that appeals to you, that is actually going to work. And that's one of the reasons why we do things in this 2D program like Illustrator or whatever CAD program you're using, is you can lay it out and you can check to see what the string pull is going to do. And you can check to see whether or not it's going, the strings are going to interfere with each other, whether the tuners are going to bump into each other, how everything is going to lay out. And once you're satisfied with that, you can kind of work your headstock shape around that design. And I know there's a temptation to want to show other people your design and ask for feedback and all this kind of stuff. That's fine, but just remember, you're the artist here, not the rest of the world. If you want to design by committee, you're never going to finish your design because you're just going to be constantly revising it, revamping it, and tweaking it and adjusting it to try to satisfy everybody who might look at the design if you're going to go that route. So at some point, you've got to design for yourself, and that's what I try to do, and that's what I've done here. Okay, so you can see that I have my fretboard laid out, and I've used that to establish the layout for the guitar overall. And then down here you'll see that I have a side view and top view of the neck. And what I'm doing here with the side view is I want to make sure that anything that I'm putting inside the neck, like in this case it's going to be the carbon fiber reinforcement strips, but if I was going to be installing a truss rod, I would be drawing out that side view of the truss rod channel, because I want to make sure that I'm going to have enough meat on the back of the neck to prevent the truss rod from being exposed as I'm sanding the back contour of the neck. Now for this top view, what this does is it's providing me with the elements that I'm going to need when I go into the next step, which is to create the 3D model. And you'll see I have the headstock here, and there's actually two pieces to this headstock. There is the front side and the back side, and this just makes it easier when I go to lay it out as a 3D model. And then I have these kind of interesting half moon shapes here, or lemon wedges, I think is the correct term. Anyway, what this is this represents looking at the front of the neck, the contour. If I were to take a saw and cut it here, this is what you would see from that viewpoint. This is going to be used along with another one at the back to form the back contour of the neck in the 3D program. But it's easy to draw them out in 2D at this stage. And then as you can see here at the back, I have the elements that are going to form the heel of the neck. So these are separate pieces which I can then extrude and build into my 3D model as I move forward. Once I have all these elements together in a all-encompassing file, and remember these are full-size, full-scale renderings or drawings, I can start to break them out or separate them into separate individual files that I'm going to be using to create my 3D models. But one thing I wanted to mention, a lot of people will wonder, why am I using 5 different programs to do this work? Why not just use one? And as I mentioned before, I like to use Illustrator as my 2D CAD program because I'm going to use these elements, these files, for different purposes. And this one that you're seeing on the screen right now, if I was going to offer this on my eGuitar Plans website as a guitar plan that other folks could purchase and then make their own guitars, this is the file that I would use to create that plan later on. So that's why I like to use Adobe Illustrator. And it also plays well with other programs like Photoshop and such, where if I wanted to do a visual mock-up, I can do it very quickly using those programs. So that's basically the reason why I like to use Adobe Illustrator. But then once I've got this overarching drawing completed, it's now time to create separate files by selecting the elements, and then I will build them. And here's an example of my body blank. And this document is actually set up to be the size of the body blank that I'm going to make this guitar body. And this is 18 inches wide and 22 inches tall, which is just big enough to fit this body. When I create this, I have to think about, when I'm cutting it with the CNC machine, what kind of clearance do I need around it, and how is this all going to fit together so that I can make sure that the blank is going to be large enough. And then I'll go to my lumber supplier and I'll purchase a board that's probably 9 inches wide and at least 44 inches in length, so I can cut it in half and glue the two pieces side by side to get the size blank that I need. But here you can see all of the different pieces: the neck pocket, the pickup pockets, the spring cavity for the tremolo, the cover that's going to be recessed for it. I even have the battery box back here, the control cavity, the jack, all the bevels. Everything has been created here so that I can import these elements into the 3D program that I'm going to use to create the full-size 3D model. I can also use some of these elements and save them out separately so that I can create SVG files, which I can then bring into Easel and use that to set tool paths and cut depths and that sort of thing. And that'll make sense later when I get to explaining how that works. And another file that I've created is the fretboard. And you saw me create the fretboard earlier, and that was basically so I could start the design, the layout of the design. But then I have to create a separate file that I'm going to use for actually generating the CNC files. And with this I have my inlay, and this is all done on one layer. Then I have the perimeter shape. Then I have each one of my frets. And then down at the bottom, what I've got here is this represents the radius of the fretboard if you were looking at it straight on. And this radius is 12 inches. So when I create that, I basically draw a 24-inch in diameter circle and then take a piece out of it that's wide as the fretboard blank here. And that becomes my radius. And I'm going to use this little element, this little piece that I drew here, when I create the file in Rhinoceros 3D to make the shape of the radius for the fretboard. So that's how I do the fretboard. And then of course each of these elements for the inlays are going to be saved as SVG files and then brought into easel so I can establish the tool paths to carve them out, because they're basically just simple 2D carvings. So that's how I create the inlay. You'll see more about that later on. And then I have my neck file, and this was basically those elements from the first overarching drawing that I did. And I've just got it oriented on a document that is the size of the blank that I'm going to use, which in this case is 5 inches wide, 30 inches long. And again, like I said before, these are all separate elements so that I can create the files that I need, whether it's in the 3D program or whether it's in easel. And I should mention, I use the 3D program to create models of the parts that are going to have contours. And any part that is going to be two-dimensional in its cut, I just create those in easel. So that's the reason why I have a 3D and meshcam process. That way I can create my 3D models in Rhinoceros, then bring those into meshcam and generate the tool paths. And that's for anything that has a contour, like the back of a neck, the radius surface of a fretboard, a carved top guitar body. That's basically where I do most of my 3D modeling and meshcam tool pathing solutions. Okay, well, that's about all the time I have for this episode, and I was going to try and actually explain the entire front-end process in one episode, but I think that would end up taking a couple of hours, which I don't want to do. So what I'm going to do is, in the next episode, part 3, is I'm going to explain how I take these elements that I created in Illustrator and then bring those into Rhinoceros 3D to create my 3D models that I use for any of the 3D carving operations. And then, you know, beyond that, at some point, either in the next episode or perhaps in what would be episode 4, I would talk about how I use the SVG files to create the 2D carving operations in easel. So, and then from there, I will build my project file that I'm going to use for actually carving this guitar. So we've probably got a few more episodes before we actually get to the cutting and carving process. So I hope you found this video to be useful. I know that there are a lot of folks who want to see even more detail when it comes to using this software, but I really have to draw the line because I don't want to be focused on how the techniques and how I use the programs, because that would take hours and hours and hours of work explaining how I learned how to do this stuff. So really the best way to do it is to find YouTube resources that specialize in explaining how to use the different programs. And hopefully you'll find this one to be useful, and the ones that will be coming in the very near future. So again, if you're new to the channel, I hope that this was of value to you and you like what you see, and you might consider subscribing. That would be awesome. And if you enjoyed the video, be sure to give it a thumbs up. That always helps me. And if you want to help to support the channel, you can always visit my eGuitar Plans website. There's a link down in the description, or you can visit my YouTube merch store, which is displayed below the description for this video. And in either case, you can purchase plans for building guitars and the tools that I use to make guitars. And in my YouTube merch shelf, you can also purchase some t-shirts as well. So until the next episode, which will be part 3, take care, stay safe, and I hope you'll be back for episode 3.